Okay, this is your Algebra 1 study guide review. Question 1 wants us to use each table to write their equation in slope-intercept form. We're looking at table A first. What we need from this table is we need the slope and we need the y-intercept so that we can write the equation. Remember that slope is change in y over change in x. Now we do have decimals in this table, and so it is okay for your slope to be a decimal. However, I would like for us to avoid that as much as possible. So instead of going from this point to this point, let's actually go from the integer, so from -3 to -2. We see that as we go from -3 to -2, that's an increase of 1. And if we're skipping there, we're also going to skip here. And so from -2 to 0, that's an increase of 2. And so we see our slope, we see our change in y, which is 1, over our change in x, which is 2. So that gives us a slope of 1/2. We also need the y-intercept from this table. The y-intercept is when x is 0. And so our y-intercept here would be -2. And so to write this equation, it would be y equals 1/2 x minus 2. Looking at B, we want the equation for that. So again, from this one, what we need is the slope and the y-intercept. So we're going to need the slope from our table, and we'll need the y-intercept from our table. Okay. So remember, our slope is change in y over change in x. Or our changes in y's, they're not changing. So that would be 0 over our change in x, which is positive 1. It's increasing by 1. Well, we know when we have 0 in the numerator, our slope is just 0. Then we look at B. We want our y-intercept. So our y-intercept here is 0 and 3.75, so just 3.75. And when we write the equation, it would be y equals 0x, which would mean that 0 and the x would just go away. And it would leave you with plus 375. So our equation for this one is just y equals 3.75. This would be our horizontal line. Looking at table C, okay, again, we need the slope and we need the y-intercept. Now on this one, we're not able to avoid the decimal part, so we're just going to be okay with having a decimal as our answer. We want to find our change in our y's. So our change in our y's for this particular case, from 0.5 to 0.75 would be an increase of 0.25. Our change in our x's would be increasing by 1. So we see that we have a slope of 0.25, or 1/4 x. And then our y-intercept here is at 1, so 0.25x plus 1. Looking at table D, we want to find our change in x compared to our changes in our y's. So our change in x, or our change in y, is -1. Our change in x is plus 1. So we have a slope of -1 over 1, which is -1. So we have y equals -1x. There's our slope. And our y-intercept for here would be at 0, -5. So our y-intercept is -5. On number 2, it says find the slope and y-intercept of the line represented by each equation. Okay, the slope for this first one is 2. That's the coefficient that's in front of x. And our y-intercept is -10. Our slope here is 4, and our y-intercept is 3. Our slope for C is 4, and our y-intercept is -4.5. Our slope for D is 2.6, and our y-intercept is 0. Our slope for E is 0, and our y-intercept is 7. Okay, 3 says use the graph to the right and find the slope and y-intercept of the line. Okay, well our slope would be change in y and change in x, or from a graph would be vertical change over the horizontal change. And so we notice that we go down from this to get from this point to this point. We go down 1, 2, 3, 4, 5, 6, 7, 8. So we have a change in y of -8. A vertical change of -8, and we're going to the right, so it's going to be positive. 1, 2, 3, 4, so we go to the right 4. So we see that we have a slope of -8 over 4, which is -2. We also see that our y-intercept is where it crosses the y-axis, and that's down at -4. So we have a slope of -2. We have a y-intercept of -4. When we write the equation, it's going to be y equals -2x minus 4. Looking for this one, it wants us to find the constant rate of change. Remember that constant rate of change is slope of each line. Then it wants us to identify the y-intercept and the x-intercept. So looking at A, we need to identify 2 points that are on that line. So this point and this point, that's a good start. We see that our decrease, we go down 1 and right 1. So our slope would be -1/1, which is -1. We also see that our y-intercept is where it crosses the y-axis. So our y-intercept in this case would be right here, and that would be at 3. So our y-intercept is 0, 3. We look at the x-intercept, that's where it crosses the x-axis, and that would be right here, and that would be at +3, 0. Looking at B, we want to do the same thing. So we want to find our slope here. Again, pick 2 points that are on that line. So maybe these two, and we see that we go up 1 and right 1. All right, so that would mean that we have a slope of +1/1, or just 1. And then we want to find the x and y-intercepts from that one. We see that our x-intercept, or our y-intercept, excuse me, is at 0, 2. And we see that our x-intercept is at -2, 0. All right, looking at this last one, okay, looking at C, we want to find our slope. So again, pick 2 points that are on that line. So I could use these two right here. We see that we go up 2 and right 1, so that gives us a slope of +2. Then we look at our y-intercept. Our y-intercept is where it crosses the y-axis, and that is at -4. And then we see our x-intercept is at +2, 0. Now, it also wants us to write the equation that represents the line. So for line A, we need the constant rate of change, which is -1. So we have y equals -1x, or just y equals -x, plus our y-intercept, which is 3. We look at the next one, we see that our slope is 1. So we have y equals 1x, or just x, and plus the y-intercept of 2. And then we have line C. We see that our slope is 2, so we have y equals 2x minus our y-intercept of 4, of -4, so -4. All right. Looking at this one. All right, let's move this. Okay, it says, does the table below represent a linear function? If so, write the relationship, and if not, it wants us to explain. Okay, so we need to find the rate of change. If there's a constant rate of change, it's linear. If there's not a constant rate of change, it's not linear. So find the constant rate throughout the table. So from 5 to 14, that is 9. And from 14 to 6, that is 12. 14 to 26, that's 12. From 26 to 32, that's 6. And from 32 to 35, that's 3. Now it appears that all of these values are different, so it's looking like it's a no. But let's check our x. So from 0 to 3, that's 3. From 3 to 7, that's 4. From 9 to 7, that is 2. Or from 7 to 9. And from 9 to 10, that's 1. So all of these values are also different. What we need to check is, are the ratios of change in y over change in x the same? So our first change in y over change in x is 9 over 3. Our next change in y over change in x is 12 over 4. Our next one is 6 over 2. And our final one is 3 over 1. What we see is that all of these are actually 3. So we see that we do have a constant range happening throughout the table. And so because there's a constant rate of change, this table is linear. 6 says, given the representations below, find the other two. So in this first one, we're given a table, and what we need to do is graph it. So we're going to graph a point at -2, 14. Let's see if we can go up to 14 on here. So we can't actually graph negative 2, 14 because our graph only goes up to 10. But we can graph 0, 8. So it's 1, 2, 3, 4, 5, 6, 7, 8. Right there. And then we can graph 1, 5. So it's 1, 2, 3, 4, 5. And we can graph 2, 2. And we can graph 3, negative 1. Okay, so there are, fix this top one up here. Okay, so there's our graph. Okay, now don't just leave points there, actually connect them. So there's our graph, and then we want to write the equation. Now I can come up with the equation from the table. That's not a big deal. So to get from 14 to 7, that's a change of minus 6. Or 14 to 8, that's a change of minus 6. And from negative 2 to 2, that's a change of plus 2. So we have a slope of negative 6 over 2, which is negative 3. And we have a y-intercept we see at 0, 8. So we have a slope of y equals negative 3x plus 8. Now here we have the graph, and we want to come up with other points in our table. So we could start with our y-intercept, which is at 0 and negative 3. And then we've got another point that appears right here. So that would be 1 and 1. And then it looks like we have another point right here, which is at 1, 2, 3, 4, 5. No, 2, 5. So we have 1, 1, and 2, 5. So every time we're going up by 1, we are increasing by, it looks like 4. So this would be 3, and this would be 9, and then this would be 4, and this would be 13. And now to get the equation, we see that our slope is 4 over 1, so y equals 4x. And we saw that we started at negative 3, so y equals 4x minus 3. Now here we have the equation. What we would do is we'd start at our y-intercept of 1, and then we would go up 1 and right 3. So we would go up 1 and right 3 to get other points. Or go down 1 and left 3. And then connect your points. Okay? What we see is that we have a point at 0, 1. We also have a point at 3, 1. We have a point at 6, 2. Okay, we have a point at, oh, I can't have a point at 3. I messed that up. Because we had a point at 0, 1. So 0, 1, 3, 2, 6, 3, 9, we'll have one at 9, 4, or 9, yeah, 9, 4, and then we'll have another one at 12 and 5. Okay, let's find the y-intercept from each representation above. The y-intercept for A was 8, for B was negative 3, and for C was positive 1. And the slope for this one was negative 3, the slope for this one was 4, and the slope for this one was 1/3. So let's determine, this one says find the value of R when the line passes through R, 6, and 10, negative 3, and has a slope of negative 3 over 2. So what we're going to do is we're going to set up our formula for slope for this one. So we have m equals negative 3. Well, actually, let's do this. So we have m equals, we have a formula of y2 minus y1 over x2 minus x1. And what you're going to do is you're going to plug in the points that you already know. So we know that our slope is negative 3 over 2. I'm going to bring the negative to the top. We have y2, which is negative 3, minus y1, which is 6, over 10, minus r. And then I'm going to condense, so we've got negative 3 over 2 is equal to negative 9 over 10 minus r. And then we cross multiply. So 2 times negative 9, that's negative 18, equals negative 30 plus 3r. That's what happens when we cross multiply there. Then add 30 to both sides, because we're solving for r, we're trying to figure out what that coordinate is. Okay? This gives us 12 is equal to 3r. And then divide everything by 3. And we get r is equal to 4. You could go back and check your answer. You could do negative 3 minus 6, which was negative 9. We established that. Over 10 minus r, which was, so 10 minus 4, which is 6. And that would simplify down to 3 over 2. Now 8 says write the direct variation equation as it relates to x and y. Assume that y varies directly as x, and then we want to solve it. So we first have to be able to write the equation. To write the equation, we know that our equation has to be in the form of y equals kx. So what we need to do first is figure out what k is. To do that, we'll substitute in negative 15 for y. We'll substitute in negative 5 for x, and we'll solve for it. We want to divide everything by negative 5 so that k becomes by itself. And we see that k is equal to 3. Now that we know that k is equal to 3, we can write our equation. The equation we would write would be y equals 3x, because we want to replace k with 3. And then we'll solve it. It says find x when y is 12. So let's make y 12. And let's solve for x. Divide everything by 3, and we get x is equal to 4. All right. The bottom part says write the equation for the line in point-slope form, then in standard, and then in slope-intercept, and then in standard form. So let's start with this. So we're going to write it in point-slope form first. Our point-slope form equation for this one will be y minus 2 equals negative 1/2 x minus 6. Then we'll distribute the slope so that we can get it into slope-intercept form. What we would do here, extend this just a little bit, what we would do here is distribute the slope of negative 1/2. Okay, negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 6, well, whatever half of 6 is, that's my answer. So that would be positive 3, because a negative times a negative is positive, and 1/2 times 6 is 3. And then we add this constant that's over here. We add this 2 to the other side. That gets y by itself, and so we have negative 1/2 x plus 5. That's going to be our slope-intercept equation. Okay, when we're moving this into standard form, the important thing here is that x and y in standard form are on the same side. So let's get them to the same side. So let's add 1/2 x to both sides. That's going to get rid of that negative 1/2 that's there. And what you're going to have is 1/2 x plus y is equal to 5. Now, we're not in standard form yet because we can't have any fractions. So because there's a fraction, let's get rid of that and multiply everything by 2. That's going to get rid of that fraction there. So we're going to have, instead of 1/2 x, we're just going to have x plus 2y is equal to 10. And so our standard form equation for this one would be x plus 2y equals 10. Let's do the same thing on part B. So we have y plus 2 is equal to 1/4 x plus 8. Remember, the negatives are going to change the minuses into adding. Now we want to change this into slope-intercept form. So to do that, we have 2 steps. We want to distribute the slope, and then we want to add that constant to the other side. So when we distribute the slope, so let's keep that part. We're going to have 1/4 x plus 2 minus 2 from both sides, and we just see that y is equal to 1/4 x. Now, that is that's our slope-intercept equation. Now, when we're moving this into standard form, what's going to be helpful here is to make sure that we put a plus 0 here, because we know that we need to move the 1/4 x over, and that's going to keep us from getting confused when we subtract that 1/4 x. So, let's subtract it from both sides. That way we get rid of it, because it's positive. We want to do the inverse of that, which we just subtract. That's going to go away, and what we have is negative 1/4 x plus y is equal to 0. Okay, now we're not in standard form yet because we cannot have negatives for a, and we cannot have fractions anywhere in this equation. So we're going to multiply everything by negative 4. That's going to get rid of the fraction, and it's going to get rid of the negative. This is going to become just x. This is going to become minus 4y, and then we'll have 0. So our standard form equation for this one is x minus 4y is equal to 0. 10. To encourage customers, a new health club is offering different ways to pay gym members to pay for a gym membership. Choice 1 is a $200 membership plus a charge of $10 per month. Choice B is $50 per month. Make one table to show the monthly charge for choice 1, and then we'll do another one for choice 2. I want to include the values of n from 0 to 12 months. So for this first option, if they do 0 months, they're still paying the $200 membership fee. And for the first month, it'll be $210. Then it'll be $220 if they go 2 months, $230, $240, $250, $260, $270, and $280 for 8 months. We're only going to 8 months. And then for choice 2, if they do 0 months, that's 0 because they're not having to pay a membership fee. They're just paying $50 per month. Month 1 would be 50. Month 2 would be 100. Month 3 would be 150. Month 4 would be 200. Month 5 would be 250. Month 6 would be 300. Month 7 would be 350. And month 8 would be 400. Okay, we want to graph this. So on the same set of axes, graph the relationship for choice 1 and for choice 2. So we see choice 1 starts at 200, and then this one's increasing by 10 each month. So we won't actually get to 250 until month 5. And then we won't get to 300 until month 10. So we can graph that relationship because it's increasing by 10 every month. And then graphing the second one, when we start at 0, month 1 is 50, month 2 is 100, and it increases by 50 all the way up to month 12. Now we want to write the equation. So this first one, for choice 1, we have a y-intercept, an initial amount of 200, and we have an increase of not 50, of $10 per month. So this first equation would be 10x plus 200. The second one is direct variation because it does not have a initial fee, but you're paying a rate of $50 per month. Now it says for what number of months will the cost for both be the same for both choices? And what we see is that the cost is the same at month 5. Now, 11 says write the slope-intercept form an equation that passes through the given point and is parallel to the graph of the equation. So what we need from this equation is the slope. That is it. So we know the slope of our line is going to be 3 over 2 because it's parallel, which means it'll have the same slope. Once I've done that, I need nothing else from that equation, so I'm going to cross it out. That way I don't get confused. Now, once we write the slope-intercept form, in order to do this, we need to start by placing this equation in point-slope form. So we'll have y minus 3 equals 3 over 2, and then x plus 2. Now, What happens for this particular one is what's going to happen for this particular one is we're going to distribute the slope, and we're going to change it into slope-intercept. So when you distribute the slope, you get 3 over 2x plus 3, because the 2's are going to cancel out there. Leaving you with y minus 3 equals 3 over 2x plus 3. Then add 3 to both sides. And what you'll get is y equals 3 over 2x plus 6. So we see that our slope-intercept form equation for this particular one is y equals 3 over 2x plus 6. Now, looking at the second one, again, we're wanting to write a line that's parallel to the one that they gave us and passes through the following point. So the point that we're given is negative 5 over 2. So we're going to use that as our slope. And then we have our point, which is negative 1, 4. I don't need anything else from this line anymore, so I'm going to get rid of that part. Put it in point slope form first. So let's put this into point slope form. So that's going to be y minus 4 is equal to 5 over 2, that's negative, x plus 1. And then distribute. So we have y minus 4 equals negative 5 over 2x minus 5 over 2. Add 4 to both sides. That's going to cancel out. Now, I do have to change this 4 into a fraction, and I have to get a common denominator. The common denominator would be 2, so this would, instead of being 4 over 1, would change to 8 over 2, and then we would add them. Now, we have negative 5 over 2x. Because this is already negative and this is positive, we're going to actually subtract them, which will give you plus 3 over 2, because the 8 is your larger number. So you have y equals negative 5 over 2x plus 3 over 2. Do not change those to decimals. I know that you don't like working with fractions, but you have to get comfortable with that. If you write it as a decimal, I'm going to mark it wrong. Okay, 12. Write the slope-intercept form of an equation that passes through the point given and is perpendicular to the graph of the equation. So our graph is y equals 5x minus 4. We know that the slope that's perpendicular to that would be the opposite reciprocal of 5, which would be negative 1/5. I have my slope. I can move. I don't need to look at this line anymore. Put it in point slope form. So we'll have y plus 3 is equal to negative 1/5 x plus 2. Y plus 3 is equal to negative 1/5 x minus 2 over 5. Subtract 3 from both sides. Again, because there's a fraction here, I have to write 3 as a fraction, so 3 over 1, and get a common denominator to be able to add those. So the common denominator would be 5. So instead of having 3 over 1, you would have 15 over 5. Negative 2 over 5 minus 15 over 5 gives you negative 17 over 5. And so our point slope, or our slope-intercept form equation here would be y equals negative 1/5 x minus 17 over 5. Looking at B, we need the opposite reciprocal slope because it's a line that's perpendicular to this one. So our slope is going to be negative 1 over 4. I don't need that line anymore. Now I'm going to put it into point slope form. So we have y plus 1 is equal to negative 1/4 x plus 5. Y plus 1 is equal to negative 1/4 x minus 5 over 4. We're subtracting 1 from both sides. Again, because I have fractions here, go ahead and make that into a fraction. Get a common denominator. So your common denominator would be 4. So instead of negative 1 over 1, we have negative 4 over 4. You're subtracting both of those, so that would be negative 9 over 4. So we have y equals negative 1/4 x minus 9 over 4. 13. Says, in 1974, a movie ticket cost $1.20, and in 2008, it increased to $9.50. Find the annual rate of change and the price of the movie ticket from 1974 to 2008. You have 2 points, okay? We have our point for 1974, which would be 1974 and 120. And we have our other point of 2008, and 950. Find your change in y, which would be 950 minus $1.20, which would end up giving you 830 over your change in x, which is 2008 minus 1974. So it's not over here. It's 4. It's 3. So 34. Okay. The annual rate of change. So that we're not quite done yet. Now we need to change this part, this 830, over 34 into into a unit rate. So your average cost per year would be 0.24 cents per year. So you need to make sure that that bottom quantity, when we're looking at per year, gets down to 1. Okay. On the multiple choice part. So it's the equation of a line that passes through the points A, B is 4 over 3 x plus 5. Which equation could be used to find BC? Now we know this is a square, so we know that squares meet at right angles. So we know that these two lines are perpendicular. So the line of BC will have a slope that is perpendicular to this one. So instead of 4 over 3, our slope is going to be negative 3/4. Now, we have a couple of lines that have a slope of negative 3/4. Our line doesn't have grids on there, but what you can look at is reasonableness. We know that AB has a y-intercept of 5. So if 5 is down here, your graph cannot have a y-intercept of 5. So this answer choice is out, and that leaves us with answer choice D. For 2, it says write the unit rate for the situation, round to the nearest hundredths if necessary. If Henry is traveling 209 kilometers in 5 hours, the unit rate would be however many kilometers he goes in 1 hour. So divide 209 by 5, and that will give you the unit rate. And that gives us 41.8 kilometers per hour. 5, it says write a direct variation equation as it relates the variable, then graph the equation. The perimeter of a rectangular pentagon is 5 times length of the side. So we have P is equal to 5 times S. Now, we can get rid of this one, but we do have to look at the other 3 graphs. We need to figure out which one goes through the origin, they all do, and which one is increasing by 5 every, has a slope of 5 over 1. So this graph has a slope of 5 over 1. So this is our answer choice, but let's look at these other ones. This one is going up and over 5. So that one actually has a slope of 1/5. So we know that one's out. Looking here, this one has a slope of not 5 over 1, but of like 3.8 over 1. So that would not be your equation. So check the slopes on the graph just to verify. Okay, which of the following equations is not equivalent expression to the others, and then explain? Well, what you would do is simplify them all. So here we want to distribute. That would give us 2x minus 2 plus 3, which would give us 2x plus 1. Here we have 2x plus 1. So we know these two are equivalent. So we know A and B are. We have 2x, no, we have 2 minus 2x plus 3, which would be 5 minus 2x, or negative 2x plus 5. So that one's not equivalent. And then let's just double check this one. We have 2x plus 1 when we combine the 3 and the minus 2. And so C is the one that is not equivalent to the others. Okay, that was your writing linear equation study guide. I hope that you found this helpful. Make sure that you study for your test, review your notes, and come prepared.